Okay, in example number 1, we want to evaluate A, sine inverse of 1/2, and B, tangent of the arc sine of 1/3. Okay, well, let's go back to some of our trig triangles. Okay, so if you recall, we know that our triangle, if this is a right angle, and this represents 30 degrees, and this represents 60 degrees, then if you recall, if this represents 1, this is 2, and if you use the Pythagorean theorem, then this is the square root of 3. Now, if we want to write this in radians, well, this is still 2, this is still 1, this is the square root of 3. Okay, so again, these are equivalent to each other. And so therefore, remember, 30 degrees is pi over 6, where 60 degrees is pi over 3. Okay, so now, if we look at another triangle that we should be very familiar with is the 45-45. So you have a 90 degrees here, this is 45 degrees, 45 degrees. Okay, and so what do we know about that? We know that if the value of x is 1 and the value of y is 1, if we use the Pythagorean theorem, then we know that this is going to give us the square root of 2. Okay, so again, using the same values here and rewriting it as in radian measure. So what is the radian measure for 45 degrees? Well, that's pi over 4, and therefore that's pi over 4. So again, you want to be familiar with these triangles when you're going through these exercises. Now, the first question that we want to ask is, okay, we want to evaluate sine inverse of 1/2. Okay, so for part A, okay, if we take a look at the graph, okay, and what do we know? We know that we have the sine inverse of 1/2. So that means that 1/2, the numerator represents the value of y, which is 1. And we know that the hypotenuse is going to be 2. Okay? So again, if we wanted to figure that out, remember the Pythagorean theorem is x squared plus y squared equals r squared. Okay? So we don't know what x is, but if we wanted to figure it out, we would say x squared plus y squared, which is 1 squared, which is equal to r squared, which is 2 squared. So we have x squared plus 1, which is equal to 4, and then x squared is equal to 3. And therefore, that's how we know that x is going to equal the square root of 3 here. And so now we know what kind of angle this is. Now, we can also look at it on this side as well. Okay, so on this side, okay, we would say that this represents negative square root of 3. We can say that this represents 1, and then this represents 2. Okay, so what we want to do is we want to be able to determine, okay, what is the sine inverse of 1/2? Well, first and foremost, what do we know? We know that the sine, when we think about the positive version of this, so we know that the sine of pi over 6. Okay, so if this angle is pi over 6, then what is the sine of pi over 6? Well, that's equal to y, which is 1 over 2. So therefore, that's going to be 1 over 2. Okay? And so therefore, when we think about the inverse, that means we want to find the sine inverse of 1/2. Well, then that means that the angle that we're looking for is going to be pi over 6. And the reason why that it's pi over 6 is because that pi over 6 lies between negative pi over 2, and pi over 2. So it's really important to remember when you're discussing the restriction on the sine function. So that answers part A. Now let's take a look at part B. Okay, so part B, we want to find what is the tangent arc sine of 1/3. Okay, so let's go ahead and draw our graph. Okay, and what we're trying to do is we're trying to find the tangent of the arc sine of 1/3. Now remember that arc sine is the same thing as sine inverse. So let's go ahead and draw a triangle here. So here we have our triangle. We know that it's arc sine 1/3, so we know that this value is 1, and then the hypotenuse is going to be 3. And so we're looking for the value of x. And then eventually we want to determine what is that angle here. Okay, so how do we find x? Well, we're going to use the Pythagorean theorem like we did up there. So we have x squared plus y squared, which is equal to r squared. So we have x squared. We know that y represents 1. We know that r represents 3. So we have x squared plus 1, which is equal to 9. And then x squared is going to equal 8. Okay, and if we simplify and take the square root of both sides, that means we're going to get x, which is equal to 2 times the square root of 2. So that means that x over here is going to equal 2 times the square root of 2. Okay, so what does that tell us here? Well, now if we continue to evaluate the tangent here, so we want to find the tangent of the arc sine of 1/3. Well, what is the arc sine of 1/3? Well, let's find that first. So remember, we want to find the angle here, the arc sine of 1/3. We're looking for the angle. So what does that mean? That means that this now becomes the tangent of theta. Because theta represents the angle of the arc sine of 1/3. Well, this is our triangle. This is theta, right? And so what do we know about the tangent of theta? Well, the tangent of theta is the value of y over x. And so the value of y is 1. The value of x is 2 times the square root of 2. So therefore, this is going to equal 1 over 2 times the square root of 2. And if we simplify that a little further by rationalizing the denominator, so keep in mind, by rationalizing the denominator, this is 2 times the square root of 2. We're going to multiply both the numerator and denominator by the square root of 2. So we get square root of 2 over 4. So therefore, the tangent of the arc sine of 1/3 is equal to the square root of 2 over 4.